This lab presents the setting of a star orbiting a supermassive black hole. We can choose our system to be the star, and it follows that the black hole is part of the surroundings. Our goal is to find the mass of the black hole given its position at the origin. Using the data that has been collected, or rather synthesized, we can construct a model in Python that reads this data and uses it to update the star's position. To analyze the forces on our system, we'll have to use Newton's second law. From Newton's second law, we get that Fnet equals dp over dt. Using this fundamental principle, we can decompose Fnet into Fnet parallel and Fnet perpendicular. Our model shows an elliptical orbit with the blue arrow representing Fnet perpendicular, the black arrow representing Fnet parallel, and the orange arrow representing Fnet. To find the mass of the black hole, we first have to find the distance between the centers of the two bodies. We can pick any point along the path of the star's motion, since we have the instantaneous Fnet at each point. We'll use the variable r to represent the distance between the center of the black hole and the star. Here we can use the Pythagorean theorem to find the magnitude of this vector, which is 8.48 e24. We can now use Newton's law of universal gravitation. It tells us that the force due to gravity equals g mm by r squared. Our model tells us that the gravitational force is 3.05 e24. Inputting the other known values, we can solve for the mass of the black hole, and we find it to be 1.96 e31. So what is the difference between Fnet and dp dt? Since they come from the same equation, are they not exactly the same? Examining what they actually refer to, we find that they are very different, but related by the equation Fnet equals dp over dt. Fnet describes the sum total of forces acting on an object, while dp over dt describes the change in momentum over time of that object while Fnet is acting on that object. The force causes the change in momentum. So put simply, Fnet causes dp dt. It follows then that Fnet parallel causes dp dt parallel, and Fnet perpendicular causes dp dt perpendicular. But suppose this black hole was switched with one of a different mass. If the black hole in our model was switched with one of a different mass, then the star's motion would change accordingly, since the net gravitational force between them depends on the masses of both bodies. But if we assume that the star's motion would not change, we would not be able to tell the difference between the two situations, and would arrive at the same conclusion for the mass of the black hole, since we derive everything from the analysis of the star's motion.